Bismillahirrahmanirrahim. In this lecture, I am solving problem point 3 from the book Applied Thermodynamics by McConkey. So, the statement of the problem is in a Carnot cycle operating between 307 degrees centigrade and 17 degrees centigrade. It means that maximum temperature is 307 degrees centigrade and minimum is 1700 degrees centigrade. The maximum and minimum pressure are 62.4 bar and 1.04 bar. Calculate the cycle efficiency and the work ratio. Assume air to be the working fluid. So the given data first for the given data first I draw PV and TS diagram. So this is PV diagram. Pressure is in bar and volume is in meter cube per kg. So the PV diagram for Carnot cycle is, this is Carnot cycle, so the PV diagram for Carnot cycle is something like this. This is from 1 to 2. This is adiabatic expansion, and from 2 to 3 this is isothermal compression. 2 to 3 this is isothermal compression, and from 3 to 4 adiabatic compression, and from 4 to 1 isothermal expansion. Now maximum temperature, similarly I draw TS diagram. So TS diagram, temperature in Kelvin, entropy in kilojoule per kilogram per Kelvin. This is the TS diagram. So from 1 to 2 this is adiabatic expansion, from 1 to 2. From 2 to 3 isothermal compression, from 3 to 4 adiabatic compression, and from 4 to 1 this is isothermal expansion. Now maximum pressure is P4. This is P4. P4 is maximum pressure and P1 is minimum pressure. So P4 is given to us, maximum pressure is given to us is 62.4 bar. 62 and minimum pressure is 1.04 bar. Now here this is maximum pressure. This is maximum pressure P4 and P2 is minimum pressure. This is P2 and this is P1 and this is P3. P1 and here pressure is P3. Similarly T1 and T4, this is constant temperature line isothermal expansion. So T1 and T4 are same. T1 is equal to maximum temperature is given is 300 and in Kelvin, convert this into Kelvin. 307 plus 273 which is equal to 580 Kelvin, and minimum temperature is 17 degrees centigrade. So in Kelvin this is T2 is equal to T3. This is equal to 290 Kelvin. So maximum pressure is P4, minimum pressure is P1. Maximum temperature is T1 or T4 because temperature is constant, and minimum temperature is T2 and T3. So in given data, maximum temperature is 307 degrees centigrade, which is equal to 307 plus 273 Kelvin. So T1 is equal to 580 Kelvin. Similarly, T2 minimum temperature is equal to 17 degrees centigrade, which is equal to 17 plus 273 Kelvin. So T2 is equal to 290 Kelvin. Now maximum pressure is P4. P maximum is equal to P4, which is equal to 62.4 bar. 62.4 bar. Convert this value into Pascal. So which is equal to 62.4. 1 bar is equal to 10 power 5 Pascal, and Pascal is equal to Newton per square meter. It means that 1 bar is equal to 10 power 5 Newton per square meter, which is equal to 624,000 Newton per square meter. And minimum pressure, which is equal to P2. Minimum pressure is equal to 1.04 bar, and 1 bar is equal to 10 power 5 Newton per square meter. So which is equal to 1.05 multiplied by 10 power 5 Newton per square meter, which is equal to 104,000 Newton per square meter. And required data is find the cycle efficiency of Carnot cycle. Cycle efficiency of Carnot, and find the work ratio. So an assumption is given in the problem. Assume air to be the working fluid. Air is working fluid. This is our assumption. Now we start solution. So in solution, first we have to find cycle efficiency of Carnot. So efficiency of Carnot depend on the maximum and minimum temperature. 1 minus T2 minimum temperature divided by maximum temperature. And percentage, this is 100 out of 100. Out of 100 is percent. Now cycle efficiency of Carnot cycle is equal to 1 minus T2 is 290 Kelvin and T1 is 580 Kelvin, multiply by 100%. So which is equal to 1 minus 290 divided by 580 is equal to 0.5. Kelvin will be cancelled with Kelvin, multiply by 100%. So 1 minus 0.5 is equal to 0.5 multiplied by 100 out of 100. So efficiency of Carnot cycle is equal to 50%. Now we are finding work ratio. So work ratio is equal to net work divided by gross work. And net work is basically work output minus work input, or work of expansion minus work of compression. Work output or work of expansion minus work of compression divided by work of compression. Gross work is work of expansion. This is basically work of expansion or work of turbine in some cases. So for work ratio, first we find work input. So net work, to find the work ratio, first we have to find net work. So net work is equal to, from the TS diagram, net work is area under the curve on TS diagram. So this area is equal to S1 minus S4 and T1 minus T2. This is Basically this is S1 minus S4 area under the curve on TS. This is this this length multiplied by this length. This is area of this whole figure. So on this TS diagram. So if we multiply S1 minus S4 and S1 into S2, sorry, temperature T1 minus T2. So this will be area of this. So here temperature is T1, here temperature is T2. So this line is T1 minus T1 minus T2, and this line is S1 minus S4. So first we will find S1 minus S4. First we will find S1 minus S4. So S1 minus S4 is equal to, basically at point 1 and point 2 entropy is constant. So we will find this is S1 minus SA minus SA minus S4, and S I define here a point A. Extend this to this point and then draw a constant pressure line. This line is from pore to A. This line is isothermal, and this point A, and from A to 2 this line is isobaric, constant pressure process. So to find S1 minus S4, this is basically S1 minus S2. I can write S4 minus S2, or S1 minus S2 minus S4. Sorry, this is S2 minus S4. These two forms. I can write a S2 instead of S1. So this is S2 minus S4, because S1 and S2 are constant entropy points. Now to find S1 minus S4 or S2 minus S4, both are same, we will replace the process from pore to A. Pore to A is isothermal, and A to 2 is isobaric process. So these are the form S1 minus SA and to SA minus. So this is isothermal. This process is isothermal, and this is isobaric, constant pressure process. So S1 minus S4 is equal to isothermal process SA minus. The formula for this is from chapter 4, or natural log of P4 divided by Pa, minus formula for isobaric process is Cp from chapter 4, natural log of Ta divided by T2. Now S1 minus S4, per year the value of R is 0.287 kilojoule per kilogram per Kelvin. Natural log of Pa divided by P4. P4 is maximum pressure. Already explained. P4 is maximum pressure, which is 62.4 bar, and Pa is the minimum pressure P2. Pa and P2 are equal because this is constant pressure line. This line is constant pressure and P2 is minimum pressure. So Pa is equal to P2, which is equal to 1.04 bar, minus Cp. The value of Cp per year is 1.005 kilojoule per kilogram per Kelvin, and Ta TA is basically maximum pressure. This is maximum pressure line, temperature line, maximum temperature, and this is constant temperature line. So T4, T1, and TA are equal, which is equal to 580 Kelvin. 580 Kelvin, and T2 is minimum temperature, which is equal to 290 Kelvin. Kelvin will be cancelled with Kelvin, bar will be cancelled with bar. So S1 minus S4 is equal to 0.287 kilojoule per kilogram per Kelvin. 62.4 divided by 1.04 is equal to 60, and natural log of 60 is equal to 4.0943 minus 1.005 kilojoule per kilogram per Kelvin. 580 divided by 290 is equal to 2, and here is natural log term, natural log of, so natural log of 2, this is natural log of this. So natural log of 2 is equal to 0.693. Now S1 minus S4 is equal to 0.287 multiplied by 4.093 is equal to 1.175 kilojoule per kilogram per Kelvin. 1.005 multiplied by 0.693 is equal to 0.479 kilojoule per kilogram per Kelvin. So S1 minus S4 is equal to, simplify this value, 1.175 minus 6. This is basically 0.696, which is equal to 0.479 kilojoule per kilogram per kilo. Now network is area on the TS diagram. So network is equal to area on the TS diagram, which is equal to S1 minus S4 into T1 minus T2. So W net is equal to S1 minus S4 is 0.479 kilojoule per kilogram per Kelvin, and T2 is equal to T1 minus T2. T1 is 580 Kelvin minus T2 is 290 Kelvin. So network is equal to 0.479 kilojoule per kilogram per Kelvin, and this is 290 Kelvin. So this Kelvin will be cancelled with this Kelvin. So network is equal to 0.479 multiplied by 290 is 138.91 kilojoule per kilogram. This is network. Now we will find gross work. So gross output is equal to, gross work is basically work of expansion. So one is isothermal expansion and one is adiabatic. So this is work from 4 to 1 is work of expansion on Carnot cycle, and second is work from 1 to 2. Now first we find for work done from 4 to 1. This is basically isothermal expansion. This is basically isothermal expansion from the TS diagram. So for isothermal process, Q plus W is equal to 0. It means that Q is equal to minus W. This process is from 4 to 1, so this is from 4 to 1, which is equal to Q from 4 to 1 is equal to minus W from this equation, which is equal to TDS. Basically Q is equal to TDS. So Q from 4 to 1 is temperature, and difference of entropy is S1 minus S4. S1 minus S4, and this is T1. So T1 is equal to 580 Kelvin, and S1 minus S4 is already known to us from the previous calculation. So Kelvin will be cancelled with Kelvin. So W from 4 to 1 multiply by minus, so this will be equal to minus, and multiply these two values, which is equal to 277.82 kilojoule per kilogram, and negative sign mean this is work of expansion or work done by the system. According to McConkey, work done by the system will be negative. Now work done from 1 to 2, this is basically isentropic expansion, and isentropic expansion is equal to U2 minus U1. U2 is equal to CVT2 and U1 is equal to CVT1. This is basically isentropic expansion. So W from 1 to 2 is equal to CVT2 minus T1, and we can write this as minus CVT1 minus T2. So multiply by minus, so again result will be this. So these two are same. So W from 1 to 2 minus the value for CV for year is 0.718 kilojoule per kilogram per Kelvin. T1 is 580 minus 290 Kelvin. This Kelvin will be cancelled with Kelvin. So simplify this value. So work done from 1 to 2 is a minus 208.22 kilojoule per kilogram. Again negative sign is work of expansion. Now work output or gross work output. Gross work output or gross work is equal to, add these two values, 208.22 work done from 1 to 2 plus work done from 4 to 1. 208.22 plus 277.82. So gross work is equal to 486.04 kilojoule per kilogram. Now we have to find work ratio. So work ratio is basically net work divided by gross work. So net work is 138.91 kilojoule per kilogram, and gross work is 486.04 kilojoule per kilogram. This kilojoule per kg will be cancelled, and work ratio is equal to 0.2857, and this is the end of the problem. And for more videos and problems, please like and subscribe my YouTube channel and share with your friend. Thank you.